Hello friends, welcome to Bindu Dhadwal chemistry lessons. Today we'll be doing exemplar problems on the chapter chemical bonding and molecular structure. Isostructural species are those which have the same shape and hybridization. Among the given species, identify the isostructural pairs. NF3 is pyramidal, whereas BF3 is triangular planar, not isostructural. BF4 negative is tetrahedral, NH4 positive is also tetrahedral. These are isostructural. BCl3 is triangular planar, whereas BrCl3 is pyramidal. NH3 is pyramidal and NO3 negative nitrate ion is triangular planar. So option B is the correct answer. Polarity in a molecule and hence the dipole moment depends primarily on the electronegativity of constituent atoms and shape of molecule. Which of the following has the highest dipole moment? So carbon dioxide is linear, so the two polar bonds cancel each other, so that net dipole moment is 0 dBi. In case of HI, it is linear with value equal to 0.38 dBi. Water has a bench shape and has highest dipole moment 1.84 dBi. So water is the correct option. Water. Sulfur dioxide is also V-shaped and its value is 1.62, which is less than that of water. So of hybrid orbitals of nitrogen in NO2 positive, NO3 negative and NH4 respectively are H is equal half of number of electrons in valence shell plus number of monovalent atoms or groups attached minus charge on cation plus charge on anion. For NO2 positive, number of valence electron in nitrogen is 5. So half of 5 plus monovalent atoms 0 minus, because it's a cation, so minus 1 and A will be 0. So the 2 is 2. So for NO2 positive, the hybridization, there are two hybrid orbitals which will be S and P. For NO3 negative, it will be half of 5 plus 0, 0 plus 1. So half of 6 is 3. So hybridization is sp2. So option B is correct answer, and for NH4 positive, it will be 4. So sp3 hybridization. Option B is the correct answer. Hydrogen bonds are formed in many compounds, water, HF, NH3. The boiling points of such compound depends to a large extent on the strength of hydrogen bond and number of hydrogen bonds. The correct decreasing order of boiling point of the above compounds will be, because fluorine is most electronegative, than oxygen, then nitrogen, so the bond formed is strongest in case of HF. But water consists of two oxygen hydrogen bonds, two polar bonds, so in all of the four options, water will have greatest boiling point, then HF, then ammonia. So option B is the correct answer. Phosphatine, the formal charge on the oxygen atom of phosphorus oxygen single bond is, so this is the structure of phosphatine. The formula is, formal charge is equal to number of electrons in the valence shell of the atom minus number of lone pair electrons plus half of number of bonded pair electrons or shared electrons. So we can see that oxygen has 6 electrons in the outermost shell, V is 6, minus lone pair electrons 2, 4, 6, plus half of shared pair electrons are 2. So half of 2 is minus 1. So the option is B. In nitrate ion, the number of bond pairs and lone pair of electrons on the nitrogen atom are, so 1, 2, 3 and 4. 4 bond pairs. whereas there is no lone pair electron, so number of lone pair of electron will be 0. Option D is the correct answer. Which of the following species has tetrahedral geometry? BH4 negative is tetrahedral, NH2 negative is V-shaped, carbonate is triangular planar, and hydronium ion is pyramidal. So option A, BH4 negative is tetrahedral. Number of pi bonds and sigma bonds in the following structure are, so number of pi bonds are 1, 2, 3, 4, 5, and number of single bonds are, let's start from here, 1, then of the double bond 1 is a sigma bond, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. So the option is C. It has 5 pi bonds and 19 sigma bonds. Which molecule ion out of the following does not contain unpaired electrons? For N2 positive, the total number of electrons are 14 minus 1, 13. So let's put 13 electron in the molecular orbitals. We have first shell as KK having 4 electrons. Then we have 2s sigma, 2s2, sigma star, 2s2, pi 2px2 is equal to pi 2py2, 8 plus 4, 12. And then we have sigma 2pz1. So this has unpaired electron. Of oxygen and molecules having electrons greater than 14, the order is reversed. Instead of pi 2px and pi 2py, sigma 2pz has lesser energy. So kk, sigma 2s2, sigma star 2s2, then we have sigma 2pz, then we have pi 2px equal to pi 2py. So 16 electrons will be placed, 4, 6, 8, 10, 12, 14, pi star 2px1 and pi star 2py1 because they have equal energy. So this also has unpaired electrons. In case of O2 2 negative, we have 16 plus 2, 18 electrons we have to put in molecular orbitals. So KK will be having, first shell will be having 4 electrons. Then we have sigma 2s2, sigma star 2s2, then sigma 2pz2, then pi 2px equal to pi 2py. Both have 2 electrons. Then we have pi star 2px2 equal to pi star 2py2. This does not have any unpaired electrons. So O2 2 negative is the molecule which does not have unpaired electron. 1. This also has unpaired electrons. In which of the molecule ion all the bonds are not equal? This has ethylene has double bond and single bonds. The single bond length is different from the double bond length, this one. So here the bonds are not equal. Option C is the correct option. This has equal bonds. Which of the following substances will hydrogen bond be strongest? So a hydrogen bond is shown only by water. Other species do not show hydrogen bond. So hydrogen bond will be strongest in water. HCl, HI, H2S do not show hydrogen bond. If the electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p6, 3d2, 4s2, then the 4 electrons involved in chemical bond formation will be of D and S, because the outermost Ns and N-1 d electrons participate in bond formation in case of transition elements. So option D is the correct answer. Which of the following angle corresponds to sp2? sp2 involves triangular planar structure, and bond angle is 120 degrees. So option B is the correct answer. The electronic configuration of three elements A, B, C are given below. Answer the questions 14 to 17. So, on the basis of configuration, A is 1s2, 2s2, 2p6. So, stable form of A will be represented by the formula A, because it's a noble gas and it does not have any tendency to give, share or accept electrons. So, it remains in a single atomic form. So, A is the correct answer. The stable form of C may be represented by the formula. The configuration for C is 1s2, 2s2, 2p6, 3s2, 3p5. It needs only one electron to fulfill its octet in the third shell. So if C needs one electron to complete its octet, another C, it can share its electrons with the second C atom to form C2. So the stable form of C will be C2. The molecular formula of the compound formed between B and C will be, B is 1s2, 2s2, 2p6, 3s2, 3p3. So it needs 3 more electrons to fulfill its octet, whereas C needs 1 more electron. So B, C, 3. Option 4 is the correct answer. Next question, the bond between B and C will be, because both B and C are deficient in electrons, so they will share electrons, so bond will be covalent in nature. Next question is, which of the following order of energies of molecular orbital of N2 is correct? So N2 has pi 2p y is less than sigma 2pz. Up till N2, sigma 2pz has lower value, is less than pi 2px equal to pi 2py. Option 1 is the correct option. Here pi 2py does not have greater value than sigma 2pz. For nitrogen, does not have greater value. So these options are not correct. Which of the following statement is not correct from the viewpoint of molecular orbital theory? Be2 is not a stable molecule. Configuration will be Kk having 4 electrons, then 2s2 and sigma star. Sigma 2s2 and sigma star 2s2. 0. So it is not a stable molecule. Helium 2 is not stable. Yes, it's not stable. But helium 2 positive is expected to exist because it has 0.5 bond order. Bond strength of N2 is maximum amongst homonuclear diatomic molecules belonging to second period. Yes, for N2 the bond order is 3, which is the strongest, whereas other elements have bond orders. The greatest bond order is 2. So this is also correct. The order of energies of molecular orbitals in N2 molecule is sigma 2s is less than sigma star 2s is less than sigma 2pz. No, pi 2px and pi 2py have lesser energies than sigma 2pz. So this option 4 is not correct. Which of the following option represents the correct bond order? 2 electrons and 3 electrons. 8 minus 5 upon 2 is 2.5. For O2, it is 8 minus 4 upon 2 is 2. Bond order is 2. And for O2 positive, it is 8 minus 3 upon 2 is 5 upon 2 is 2.5. So the correct option will be option B. O2 negative is less than O2 is less than O2 positive. This is 1.5, this is 2, this is 2.5. That's all in today's video. Thank you. Have a nice day.